Hi folks, the Bald Guys back with IoT channel. In the last episode we showed you which tools can be used to cleverly connect sensors with the SAP Cloud Platform. Today we'll show you what it looks like in real life. We will periodically read out the CPU usage of my laptop, send it to a local MQTT broker, mirror it with a cloud broker, and send it to a SAP IoT thing with a Node-RED via HTTP request. And we show everything step by step. Let's get started! Before we read out our sensor, we must first install Node-RED. You can find instructions on the website of the Node-RED Foundation. I posted the link in the description of this video. If Node-RED is installed and running in your browser, you can start installing the local MQTT broker. Fortunately, you can do this directly from Node-RED. I've also added a link to a wonderful explanation video. If you follow the instructions, you have installed the lightweight Mosca MQTT broker. Many thanks to Steve Cope for the helpful video. Now we have everything we need to get started. Depending on your task, there are different ways to read your sensor. Maybe you are using an Arduino or a Raspberry Pi, or your sensor sends via ESP8266. The possibilities are endless. We decided to measure the CPU usage of my laptop because it changes quickly and is easy to read using Python. Here is my Python script. It runs on a Jupyter Notebook. Jupyter Notebook helps me to write and execute the code quickly. I use the libraries psutil to read the CPU usage and Paiho MQTT client to connect to our locally installed Mosca MQTT broker. Paiho MQTT you can install in Jupyter Notebook with this command. The program itself is very simple. First, I connect to the local MQTT broker on localhost port 1884. Then I read out the sensor and publish it to the MQTT broker under the topic Test CPU Usage. When I start the program now, it sends the CPU usage of my laptop to the local MQTT broker every 20 seconds. We can simply test this with another small Python program that we see here. There we read out our MQTT broker with the topic test hashtag, where hashtag is here as a wildcard for all topics under test. The program displays the content of all topics under test. This means our sensor is up and running and we can continue with our next step. So far, I don't think you've seen why it's all so easy now. We had to write Python code, install libraries, and set up MQTT broker. But I promise you, from now on, you will understand why everything suddenly becomes so easy. Because from now on, we do everything graphically, with Node-RED. Here you can see everything you need to send your information to the SAP IoT Foundation. But stop! One thing we still have to do. All important information about SAP IoT applications can be found under a link which I also put in the description of this video. You can find out how to create an IoT thing and where to find out the URL to which you have to send the data in another link in the description. Here you can see my thing that I created with the thing modeler. And here's also the value CPU usage. The most important thing when creating a thing or device in SAP is the device ID and the token. You get this information when you have successfully created the new thing. It's a good idea to write it down. We need this information later to start an HTTP request from Node-RED. I have received the following information for my device. The thing ID, also known as device ID, the token, the ID of the host the IoT Foundation is running, the API address, and the ID of the message type. The host ID, API and thing ID we need to create the URL. This is a lot of information, but most of it is redundant for each additional sensor. The token is needed for the verification during the HTTP REST request. And the message type ID we need in the structured message itself. We'll come back to that later. Only the thing ID and token change for every new sensor. Therefore, you can add more sensors very quickly later in Node-RED. By the way, Node-RED. That's where we stopped earlier. But now. Okay folks, we made it. From now on, it's just clear and simple. But one after the other. First we get the data from the local MQTT broker on my laptop and store it on an MQTT broker in the cloud. This mirrored broker in the cloud is called Bridge. It has the advantage that more subscribers can easily access this information from anywhere in the world. For example, I can use it to view the CPU usage on my smartphone with a simple MQTT dashboard app. But more about that later. Let's see if that works. We connect one of our nodes to read the local MQTT broker with our MQTT cloud broker and connect a debug node and wait until the sensor sends the next time. Et voila! We get the CPU usage. Now we can start sending this data to SAP. And again we get the CPU usage first from the MQTT cloud broker. You see how easy it is? Now we need a timestamp. There is a function node for this. In this node you can edit the information that flows with JavaScript. JavaScript is object-oriented and the information, the message object MSG, can easily be extended by further entities. Here we do this by simply defining a new entity, it means msg.time, and assigning a timestamp to it. That's all. The entity MSG payload always contains the information from the previous node. Therefore, we now assign MSG payload, it means our readout CPU usage, to the new entity MSG CPU. We will soon see how we can use this later. So we have restructured our message object and added a timestamp. We continue with the preparation of our CPU usage for sending to SAP. Now we have to prepare the message so that the API understands it. Since we are working with a POST request, we need a header to log on to the server. We create this header here. Now you understand why you need the token. With this token, we log on to the server. The message is now provided with a message type ID, and the information, CPU usage and timestamp is read from the message object and inserted into a mask. Altogether we get the new message object msg.payload. Now we have almost done it. In the next node, we put our host address, the API address, and the device ID together. This results in our URL. We set post as the request method, and that's it. And let's activate it. So that you can see that all this is not faked, we send a request to the API, which last records have been delivered to the API. And it fits. If you take a look at our thing in the SAP IoT system now, you can see the last measured value here. From here on, you can use the full power of an SAP system with big data, analytics, or machine learning. Maybe more about that later in another video. Now we have covered the entire distance from sensor to SAP IoT system. Maybe you didn't find that easy. But look at it this way. With MQTT and Node-RED there are a few major advantages. With MQTT you can easily connect additional subscribers who are interested in the sensor data. For example, an MQTT dashboard on a smartphone. This allows me to read all important information and send control signals at any time. Mirroring the data into the cloud is super easy because you can use the hashtag to mirror all the information in a topic at once. That means if you connect more sensors to the local MQTT broker, they are automatically transferred to the cloud MQTT broker. Node-RED saves us the documentation because everything is always visible. There is no exe runtime, the program always runs visibly. Connecting further sensors to the SAP system is very simple. You simply copy and paste the existing nodes and you have the next sensor connected in 1 minute. The information can be branched off and changed at any time. Entire flows can be copied for test purposes. And Node-RED also has its own dashboard. Data can be written by Node-RED directly into databases or sent by email. The possibilities are endless. Your imagination is the limit. I'm sure you'll agree that with MQTT in combination with Node-RED, we found a simple and stable concept how to transfer data to SAP Cloud Platform IoT Foundation. Have fun trying out for yourself. What do you think of Node-RED and MQTT? Write your opinion and your questions in the comments. And don't forget to like. That's all for today, folks. Goodbye.